don't have to record 7 periods. So fingers crossed it works. So I have a recording of today. Friday we had a work day. A lot of you were absent, a lot of field trips and stuff like that. So Friday we worked on the progress check or homeworks or whatever. So just remember the progress check is due tomorrow night at midnight, 11:45. So make sure you get that done. In fact, the homework today won't take you very long. You'll have a lot of time left over after the homework today. So if you want to work on the progress check in class today, you've got a good chunk of time. I also checked the test review on Friday, 322. So if you weren't here on Friday, I'll just come around and check it with you guys when I'm done with the notes. Okay? So here we are, we're in 3.9, day 1, and tomorrow we'll finish it. And we're talking about inverse trig functions. And we've talked about inverse functions in general back in 2.8. And I'm going to remind you of that here. Okay? So you don't need to write this. I just want to kind of remind you about inverse trig functions. So a function. A function passes the vertical line test, has no repeat x values. Okay? Here's a parabola, right? A quadratic. This is the parent function. It's a function. Okay? But whenever we have to find an inverse, there's a couple different ways we could do it. We could switch all the points in the graph, because those are just x, y's, or like in the xy chart, because inverse is just switching x and y's. We also did it in the equation. We would switch x and y and then solve for y. And so here's the thing. A parabola is a function, but it's not invertible, which simply means the inverse is not a function. Let me show you the inverse of this function. So this is what it looks like algebraically. This is what it looks like graphically. Here's that XY chart flipped. You don't need to be writing any of this. But it doesn't pass the vertical line test. There's repeat X values. So let me repeat this. This guy is a function. A parabola, a quadratic, is a function, but it's not invertible because when we switch X and Y, in other words, find the inverse is not a function. So there's something we do to fix that problem, and that's called restricting the domain. So if you look, plus or minus the square root of x is the plus and the minus. Both halves of those are what cause it to not be a function, right? We're repeating x values. So if we just do 1/2 of it, which is what we would do, we would restrict the domain. Just say we're only going to use this part of the domain, then it becomes invertible. It's a little bit of algebra magic, okay? And the same thing is going to happen with sine, cosine, and tangent, all right? Before I get to that, though, I want you guys to notice right here, this is the notation. So back in, like, algebra 2.8, working with any kind of polynomial, we would use this little symbol, and that would mean inverse. We saw the little -1. I don't know if you remember, but that's what we did. And so with sine, cosine, and tangent, you'll still see that little -1 after the word sine, cosine, or tangent. But there's a second way of showing inverse, and that's using this arc word, A-R-C. These mean the same thing, okay? This you'll start seeing a whole lot in calculus. They use arc sine, arc tan, arc cosine in place of the -1 quite a bit, but they're both used, they're both valid, they both mean the same thing. It doesn't change how you do anything, and I'll point that out to you as we go, just because it seems to be the #1 question I get. What do I do when it says arc? It's like the same thing as the other one, okay? All right, so let's just take a quick look at the graph of sine. Here it is. This is sine. Middle up, middle down, and it repeats forever and ever. Sine is a function. It passes the vertical line test. But if I do the inverse of sine, it would not be a function. Pretty much, it would just look like this. This would be my x-axis. This would be my y-axis. And you can see it doesn't pass the vertical line test. And a quick way of being able to tell if something is invertible, meaning its inverse is a function, is doing the horizontal line test. So back to my parabola real quick. This passes the vertical line test. It's a function. It fails the horizontal line test. That means its inverse is not a function. Same thing here. Sine fails the horizontal line test, which means its inverse is not a function. So just like we do with polynomials, we restrict the domain. So somebody universally decided when we do inverse sine, we're going to use from here to here. It's the closest points around 0, 0. We like to stay in the middle. We know a lot about this part of the coordinate plane or the graph. And so that's from negative pi over 2 to pi over 2. So here you can see that little section chopped and just graphed by itself. And then this is the graph of the inverse. So you can notice in this diagram, the x-axis are our thetas, and the y-axis is the sine values, and here it's flipped. You don't ever have to graph any of this. What I want you guys to take away from this is that whenever we're doing inverse sine or arc sine, same thing, we only use these two quadrants of the unit circle. We use from pi over 2 to negative pi over 2. So this uses quadrant 1, regular old boring quadrant 1. But when we're talking about negative pi over 2, think about what that is on the x-axis. Those are numbers that are less than 0. On the unit circle, that's traveling in reverse. So it's not our traditional quadrant 4, because at 5 we go to 7, 11, those angles. We get those angle measures by starting here and terminating. You have to travel all the way around to get angles this big. What we're talking about here is, and I use this word, I don't even know if it's proper, but backwards quadrant 4. It's just starting at 0, 0, but going clockwise, which makes these angles negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. So quadrant 1 and backwards quadrant 4. Let's look at it a different way. Here's a table of values with those thetas, right? Negative pi over 2 to pi over 2. All of our standard angles, the ones we memorize. And what I want you guys to do is quiz yourself, because I'm going to tell you this whole entire lesson, everything is about this. This right here. There is a reason I made you guys do this. It wasn't to torture you or, watch you squirm. You had to know your trig for lessons like this and lots of them coming up. Because right now, I have my unit circle here. You might have a unit circle in front of you, but you won't when it comes time to test on the AP exam or my exam. You have to have the trig in your brain. So what I want you guys to do real quick before I tell you what the assignment is, like what the actual problems are that we're doing, is take a second and see if you can quiz yourself. Can you come up with what is sine of pi over 6? What is sine of pi over 4? And so on. And just do a quick quiz of yourself. Everybody try it real quick. I'll give you a minute or so. And see if you can come up with these just from memory. If you can't, that's okay. I'm going to go over them. But give yourself a chance to try to find these values just from memory. So here we are in quadrant 1. In quadrant 1, sine is positive, and in quadrant 4, sine is negative. So the values are the same, right? Remember, the thing we start with on the unit circle is our denominator of 6, right? And it looks like this. You have to know that, because that tells you everything, right? So for my denominator of 6, sine is the y value. That's where I got the 1/2. Denominators of 4, denominators of 3, and then when we get over to quadrant 4, backwards, either way, sine is negative there. So it's the same numbers, right? 1/2, square root of 2 over 2, and so on, but they're negative in quadrant 4. And then at my quadrantals, I don't mess around with my quadrantals. That's where I tend to make my mistakes. If I'm going to make mistakes, that's where my students tend to make their mistakes, is the quadrantals. So I'm always really careful there that I know what I'm going to get. So if you look, we use from -1 to 1. Those are all of my sine values, my range for these thetas, okay? So again, inverse sine or arc sine, same thing, is from pi over 2 to negative pi over 2. So what you're going to be asked, guys, is the reverse of what I asked you on here. Here I gave you theta, very specific place on the unit circle, and you had to give me the sine, the cosine, or the tan. Well, this is in reverse. Here, I'm giving you the trig value. You need to tell me the theta. The answer to all of these should have a pi symbol in it. What angle does this happen in one of these two quadrants? Now, you could look at your chart here, but you don't want to look at your chart, okay, because you're not going to have that. So, again, this is the process you would go through. When I see a sine or a cosine with a 1, a -1, or a 0, I know it's a quadrantal. So I start like thinking about my ordered pairs. That's 1, 0, okay, that's not 1, okay, up at the top, down. Okay, there it is. So I get a sine of 1 up at the top. It would take me about that long to come up with it. It's never that quick for me with my quadrantals. But I think about my ordered pairs, and then I think sine is the y value. Okay, that happens up at the top. That's pi over 2. Okay? My sine of 1/2, that's when square root of 3 comes first, so 1/2 is the second one. That's my denominators of 6. And since it's negative, it's not quadrant 1, so it's going to be backwards quadrant 4. What's your question? Where in this half of the unit circle do I get a sine value of -1/2? Right here, which is negative pi over 6. Okay? So look, what is the theta? What denominator gives me square root of 2 over 2 for sine or cosine? What's the denominator? 4. Okay? And then if it's positive, that's quadrant 1. If that were a negative, it'd be a negative pi over 4. It's the only two you can have. It's either pi over 4 or negative pi over 4. It's one or the other. Okay? And 3 over 2, we don't have a 3 over 2. This does not exist. 3/2 is 1.5. We don't go above 1. This is from -1 to 1. We don't go above that. So, plus it's not something we know. It's not a number we know. Okay? All right, so I have to do the same thing for cosine and tan. I'll go a little faster over the explanation. You never have to spit this out, but I'll have to be a professional math teacher and explain it to you. Here's the graph of cosine. Up, middle, down, middle, up. It just keeps repeating. It is a function. It passes the vertical line test. It fails the horizontal line test. So for the inverse of cosine, we have to restrict the domain, just like we did for sine. But instead of using from negative pi over 2 to pi over 2, which wouldn't solve the problem, right? That fails the horizontal line test too. We use a different section, which is 0 to pi. From 0 to pi. I call cosine sunrise. It just uses those two quadrants, from 0 to pi. We're positive in quadrant 1, or negative in quadrant 2. But only those two quadrants, and you can see the rest of the graphs. But let's go right to quizzing ourselves. From 0 to pi, we've got quadrant 1, we've got quadrant 2. See if you can come up with those values on your own. Now, if you're struggling with this, first of all, what level of struggle are you? Are you having no idea where to start? Are you remembering some and not the others? Is this really simple to you? Figure out where you are, because the bottom line is everyone has to be at the point where you just get it, okay? You're not going to have it in front of you. So any question that has any of this trig stuff on it, if you don't know it, you are just guessing, okay? And we don't want to guess. So again, we're in quadrant 1 or 2 only for inverse cosine. In quadrant 1, cosine is positive, and quadrant 2, cosine is negative. But the values are the same, right? So again, going through these, okay, 1, 0, okay, it's not there. Oh, it's up at the top. 0 is the x value. That'd be pi over 2. Right? That's the ordered pair up there. Cosine is the x value. What is that theta called? Pi over 2. How do I know what? Well, because I know the whole unit circle, I know cosine is the x value, so I'm scanning the unit circle in my head. Where do I have a cosine of 0 at pi over 2? It's the only place in quadrants 1 or 2 that happens. There is no 2, because cosine, again, just like sine, only goes from -1 to 1. 2 is not any number I wrote. There's no 2 in there. It does not exist. Okay? Square root of 2 over 2, that's my denominator of 4. It's either quadrant 1 or quadrant 2. Well, cosine is positive in quadrant 1, so that's how I know this is pi over 4. All of my denominators of 3 start with 1/2. If it's negative, it can't be quadrant 1, so it must be quadrant 2. Okay. And lastly is tangent, and I'll put these all three side by side for you in a second. Tangent is a function, squiggle, 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 keeps on going, fails the horizontal line test, so we must restrict the domain, and we just pick that middle squiggle and use that. And what's nice about inverse tan is that it's the same part of the unit circle as inverse cosine. So we use quadrant 1 up to pi over 2, and backwards quadrant 4 to negative pi over 2. So sine and tan use the same exact part of the unit circle. Cosine is the only one that is different. I call it sunrise, but I'll put them all side by side for you. So last one of these, guys, quiz yourself here, okay? Remember, tan is y over x, but I taught you tricks for all of your denominators of 6, 4s, and 3s. You really only have to know y over x for your quadrantals, okay? So see if you can remember what these are, the tan tricks. Remember, your denominators of 6 is the square root of 3 over 3. It adds up to 6. Denominator of 4 is 1. Denominator of 3 is square root of 3. I taught you those tricks, which happen in every quadrant. The signs just change, right? Quadrant 4, we would have negative tan values. And then be careful at the quadrantals, y over x. So when I do negative 1 over 0, 0 on the denominator is undefined. Same thing over here. 1 over 0 is a 0 in my denominator. That's undefined. So at the top and the bottom, tan is undefined. Okay? But at 0, that is 0 over 1. A 0 on top is just 0. That's where I'm getting this. So remember that. 0 in the denominator, undefined. 0 in the numerator is 0. So again, just going through these. Tan values of 1, that's a denominator of 4. I have a choice of quadrant 1 or quadrant 4. If it's positive, quadrant 1. Square root of 3, that's my denominators of 3. Right? And it's not quadrant 1, because quadrant 1, everybody's positive. So it's got to be backwards quadrant 3, which is just negative. Right? Just going the other direction makes negative thetas. Tan of 0. Yep, it's where my ordered pair is 1, 0, which is at 0. Or you could write 0 pi. Either one is fine. 0 or 0 pi. And then square root of 3 over 3, that's my denominator of 6. Quadrant 1 is where we're positive. Okay, so this is really this is really a test of your trig knowledge. You have to know it. So if this was hard for you, if that stressed you out, you've got to go back and practice. If you need some blank unit circles, I'll dig some out for you, but we can't forget it, right? And before I sum it up for you, I'll draw you like a little thing for you guys to have right in front of you in a second. Let's just do this last example. This is where they're asking you to use your calculator to find them, right? Because the ones we just did are ones we know. They're called our standard angles. These are their standard ones. But there's all other angles in here in between. Like between 0 and 30, think about how many angles we could make. We just don't have them memorized. So sometimes we go to our calculator. So if you see inverse sine or arc sine, they mean the same thing. That means that. They mean the same thing. And that button on your calculator, find it, is right above sine, cosine, and tangent. See how they have the little -1? So you're just putting it in your calculator. Second sine, 1 divided by 4. And rounding, even though it says, I think in the homework it says 2 decimal places, let's just do 3 decimal places because that's what we're supposed to be doing on the AP exam. So these are like freebies. Can you put it in your calculator and round correctly? Second cosine, -3/5. You get 1.352. And I would definitely put this one in your calculator so you can see what it looks like when you get a does not exist. The calculator tells you there's an error. So you would write D and E. Because remember, it's only from -1 to 1. This is greater than 1 right here. So it makes sense that your calculator won't let you do it. Okay? So if you want to find like a little space like right here or something to write what I'm going to write, you can. Everything I'm about to write, I gave you in the notes anyway. So let me just show you what I was going to write. So just like a little, just to sum it all up. Inverse sine and inverse tan, also known as arc, sine, and arctan. Means the same thing, uses this half of the unit circle from pi over 2 to negative pi over 2. We're positive in quadrant 1 and negative in quadrant 4 for both sine and tan. This is something you have to know. Okay? And then cosine, also known as arc cosine. It means the same thing. Uses what we call sunrise from 0 to pi. We're positive in this quadrant and we're negative in this quadrant. Okay? So when you go to do this homework, guys, you can copy my key and be done in 30 seconds because it's that quick. There's really no work to show. It's just finding the stuff in your brain. But don't do that to yourself, okay? Use this as an opportunity to review your trig. And as you write down, as you get to a new problem, try it first. See if you can get it without looking at the key. Then look at the key to see if you got it right, okay? Don't just copy. Please, please, please. You're doing yourself no favor. Good? Have it written down? Let me know if you have a question. Can you check the test review for anybody that was not here?